Brushless motor control principle. The traditional control method of a BLDC motor is to switch the power circuits, IGBT or MOSFET, to supply current to the stator coil based on the Hall sensor signal. This control mode is also known as 120-degree control mode. This is the basic control mode for a brushless motor, and we will not consider other modes for the time being. At any given time, the motor always has only two conducting phases, so this is also called a two-phase control mode. Under each conducting phase, we see that there is a unidirectional current and a unidirectional electromotive force. Therefore, a BLDC motor will have similar mechanical and control characteristics to a DC motor. That's why this motor is also called a brushless DC motor. During the startup process, the BLDC motor runs at idle after closing the load. We can clearly see that the phases, along with different colors, take turns conducting electricity and demonstrate their one-way nature. To implement the above motor control principle, a control configuration within the current hysteresis range, also known as hysteresis current control, or HCC, has been implemented, and it is an exemplary control configuration for BLDC motors. It is easy to see that, when using the HCC current regulation method, we have the switching current up to 6 times in one cycle. This switching is not ideal, not instantaneous, and the up and down switching times are not equal, causing the shortcomings of BLDC motors, which are fluctuations in the magnetic flux trajectory, which is not circular and is difficult to determine. Torque ripple is considered the weak point of BLDC motors. Recently, there has been a large amount of research on BLDC motors aimed at minimizing this undulation. Normally, the magnetic flux trajectory of the motor must be circular, but due to the non-ideal switching of the current, the flux trajectory of the BLDC motor has up to 6 spikes and steps in one cycle. Estimating the magnetic flux at these steps is very difficult, making it challenging to control the magnetic flux in a BLDC motor. Therefore, the control of BLDC motors up to now has ignored the process of controlling its magnetic flux. Diagram and control of brushless motor. A BLDC motor has up to 3 wires, while its module only supports 2 wires. So what to do? We will use a new control device called an escape. The escape has the speed regulation function for the brushless motor, which is operated by sending pulses to the signal pin. The wiring diagram is as follows. Right, includes 3 wires connected to 3 motor wires. Note, connect the middle wire of the escape to the middle wire of the motor, the remaining 2 wires can be connected either way. Reversing these 2 wires will only change the direction of the motor. Left. Of 2 large wires that supply power to the motor. We see that the 3 smaller wires are quite similar to the 3 servo wires, as they work in a programming code quite similar to a servo motor that works with pulses. The function of these 3 wires is as follows. The black wire is the negative pole, the red wire provides 5 volts power, and the yellow wire is the signal wire connected to the Arduino, connected to the PWM pin.